Ladies and gentlemen, welcome to section 4.4 complex numbers. But before we get into some complex numbers, we first have to deal with squares and square roots. So we're going to start with 3 times 3. Yes, we all know that 3 times 3 is 3 squared, and then 3 squared is 9. But then how would you undo this? If we had the square root of 9, we could also write it as the square root of 3 squared, and then the square root of 3 squared would be 3, or you could just look at it as square root of 9 is 3. How about 5 times 5? 5 times 5 is 5 squared, or 25. So the square root of 25 must just be 5, as that square root undoes this square. How about x times x? X times x is x squared. The square root of x squared would just be x. So these fancy numbers do have a name. They are called perfect squares. The perfect squares are under the square root. All right. Take note. These are the perfect squares. All right. That all come out very nice. So the square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. All of those numbers are perfect squares. So let's simplify some of these. So the square root of 81. We look. Do we see an 81? Yes, we do see an 81. The square root of 81 is 9. Perfect. Easy enough. Well, how about number 2, square root of 48? Do we see in the blue numbers? We're looking at the blue numbers. Do we see the square root of 48? No, we do not. So then we have to go to the blue number or a perfect square, a blue number or a perfect square that goes into 48. So I'm going to start at 49. Does 49 go in there? No. 36? No. 25? No. 16? Wait a second. 16 does. 16 goes into 48. 16 goes into 48 3 times. Well, what is the square root of 16? The square root of 16 is 4. So now 16 will come out of the square root and be 4. What's left inside the square root? Just a 3. So your simplified answer would be 4 square root 3. How about 72? Same thing with 72. Is there a 72 in a blue number? No, there is not. Well, then we have to go to, is there any blue number that goes into 72? Starting with 64. No. 49. No. 36 goes in there how many times? 36 goes into 72 2 times. So I take it times 2. Well, 36, the square root of 36 is 6. So 36 comes out of the square root and is a 6. I cannot do anything with that 2, so we're left with a square root of 2. And then finally 27. Is there a 27 in the blue numbers? No, there is not. So let's start with 25. 25 doesn't go in there. 16 doesn't go in there. But 9 does. And how many times does 9 go in there? 9 goes in there 3 times. The square root of 9 is 3. So the 9 comes outside of the square root, turns into a 3, carry down the square root, and what's left, which is 3. Awesome. Now that leads us into the square root of negative 16. What is the square root of a negative 16? Well, 4 times 4 gives me 16, but a negative, how do I get a negative? Well, I can make 1 a negative, but is that the same thing times each other? No. Well, if I make the same thing times each other, negative 4 times negative 4, that gives me a positive 16. So can we take care of a square root of a negative number? And as of today, we can't, but now we can take a square root of a negative number. And it is called an imaginary number, or an imaginary unit, is the square root of negative 1. You'll see a lot of i's today. I's equal the square root of negative 1. Pure imaginary numbers are the square roots of negative real numbers. Now, a quick little add-on about imaginary numbers. We all know that I equals the square root of negative 1, and then I squared must be I times I to get I squared, and then I is the square root of negative 1 times another I, which is the square root of negative 1, making that all equal the square root of -1 squared, but what do you think that square and the square root do to each other? Well, they cancel each other out, leaving just -1. So I squared must be -1. Here we have I to the third, or I cubed. Well, I cubed is made up of an I squared times a I. Well, I squared turns into be a -1 from right here. And then we have I, which stays I. So I to the third then turns into a negative I. And then finally, I to the fourth. Well, we know that I to the fourth is made up of I squared times I squared. I squared, what's it turn into? Oh, well, that's a -1 times another -1. And we know that -1 times -1 is 1. So I to the fourth is just a 1. So how does this relate to us? How does this help us out? Well, I to the 13th. I to the 13th, we can figure that out by taking I to the fourth times I to the fourth times I to the fourth. Well, that's 12. We need one more, so it has to be times I. Well, I to the fourth is just 1 times 1 times 1 times I. So I to the 13th is just I, because 1 times 1 times 1 times I is I. How about I to the 23rd? Well, I don't want to do it the same way as this, because that would be a lot of I to the fourth, right? It would be I to the fourth times I to the fourth times I to the fourth. I'm already getting tired of writing I to the fourth, but there are 5 I to the fourth times I to the third. All of these guys turn into 1, and then I to the third turns into a negative I, so our answer would be -I. Well, there has to be a better way of doing this, right? Sure there is. Take 23, divide it by 4, right? So I'm going to do it the old-fashioned way. I'm going to go 4 outside, and I'm going to put 23 inside. 4 goes into 23 how many times? 5. 4 times 5 is 20. I subtract to get 3, so I have a remainder of 3, right? That would be your I to the third. Again, I to the third equals a negative I. How about I to the 24th? Again, that would be writing a lot of I to the fourth, so let's just take our power of 4 and divide it into 24. 24 divided by 4 is 6. Oh, that's an even number. What does that tell us? Well, that tells us that there is no remainder. So I to the fourth goes into I to the 24th 6 times with no remainder, so that has to equal just a 1. That means that there's I to the fourth in here 6 times. It would just be 1 times 1 times 1 times 1 times 1 times 1 times 1, and it all equals 1. And finally, I know this isn't an imaginary number, but it's the square root of x to the fifth. Let's pretend that there is a 2 right above this square root. Well, this 2 goes into that 5 2 times, so I'm going to pull that out. But remember, it's an exponent, so it's going to be x squared. Now, what does this mean? Well, this means that I have this square root with that little 2 right there of x squared times x squared times x. I just took out one of these and one of these, right, to get x squared. What's the remainder? What's still inside the square root? That is going to be the square root of x. So this bad boy right here simplifies into this nice x squared times the square root of x. Now let's simplify a negative 16, or square root of negative 16. Well, let's rewrite this as 16 times -1. 16 can be found in the blue number, and that's 4. So I can take 16 outside the square root. It turns into a 4. Well, from our last slide, what is the square root of a -1? The square root of a -1 is I. So 5 would be rewritten or simplified as 4i. How about -125? How can we rewrite that? What is a blue number that goes into 125? Well, that is 25, and it goes in there 5 times, but we can't forget about our -1. So 25 comes outside the square root, turns into a 5. Can we touch this 5? No. How about this? -1. It comes outside the square root and turns into an I, where you're left with the square root of 5 still inside. How about number 7? 7. Now we have 3 times 4, so that's just 12. Nothing changes there. But how about an I times an I? I times I would be I squared. Now, I squared, what is I? I is the square root of -1. I squared means that it's square root of -1 times square root of -1. Well, the square roots would undo each other, so I squared must be a -1. Big key right there. I squared is -1. Big key. Hint, hint, wink, wink. Then we have 12, and what's I squared turn into? A -1. 12 times -1 is -12. So 7 simplifies to -12. Now with 8, what blue number goes into 12? Well, I know, and I'm going to change my color real quick. I know that 12 is the same thing as 4 times 3 times a -1, and then still times the square root of a -1 times 2. So what can I take out right now? I can take out a 4. The square root of 4 is 2. The square root of -1 is I. You are left inside with a square root of 3. How about this guy? I can take out the square root of -1, which turns into I. We cannot touch the square root of 2, so I leave that in there. We are still multiplying each other. Now when I multiply the 2i and the I get 2i squared. Now I can also multiply the square roots to get the square root of 6. I can't touch the square root of 6, but what's the I squared turn into? It turns into a -1, so it makes everything negative. So it's going to be -2 times a square root of 6 for your answer. Trying some more. Now we're solving for x squared. So with 9, we want to get x squared by itself. So we are going to subtract 64 from both sides to get x squared equals a -64. How do you undo a square? Well, we undo a square with a square root. So now we have x equals the square root of 64 times -1. Do you agree? Well, what is the square root of 64? The square root of 64 is 8. And then the square root of -1 is just an I. And then remember that is what x equals. Trying another one, number 10. Our goal in these problems is to get x squared by itself. So the first thing we have to do is subtract the 20 over. So we have 5x squared equals -20. In our order to get x squared by itself, we have to divide by 5. So we divide both sides by 5. So we get x squared equals -4. How do you undo a square? You have to square root both sides. So then we get x all by itself. And then we are left with the square root of 4 times -1. Now we can square root the 4, which turns into a 2. Square root the -1. That turns into an I. And what equals that? And that would be x. So we found x. Now we are on to a complex number. A complex number is any number that can be written in the form a number plus bi. A is just represented by a real number, b is also a real number, I is the imaginary unit. So a complex number would look like that. So Now we are asked to simplify something like this. Remember, with adding binomials, what do? We just combine like terms. So we just add. We're going to drop the 3 plus 5i right out of the parentheses, plus 2 minus 4i. We combine like terms, just like you're adding variables. We have 5 plus, and then 5i minus 4i is just 1i, or 5 plus I. Over here, now with a negative, what do? Make sure we distribute that negative to both things behind there to get a negative 3 plus 7i. Bring out the first binomial to get 4 minus 6i. Combine like terms here and here, turns into a 1. Now you have a negative 6i and a plus 7i, which turns into another plus I for your simplified answer. 13, now we're asked to find the values of x and y that make the equation like this true. Something like this, all we have to do is set your real numbers to each other. So since there's no I here and no I there, I'm just going to go 2x equals negative 14. Now I'm going to solve for x. I divide by 2, so x equals negative 7. Here I have i's. So now I'm going to set those equal to each other. Y and the imaginary number equals negative 3i. How do I get this y by itself? I have to divide by I. So I divide by I. Y now equals a negative 3. So you found x and y to make this guy true. Now with 14. 14 is just like your multiplying binomial. So 2 times 4. We have to take this guy. So we have 8. And then 2 times 5i to get plus 10i. And now we move on to the 3i. There times there to get plus 12i. And now careful here though, because 3i times 5i is plus 15i squared. Now let's simplify this mess. We get 8 plus, this turns into 22i. This turns into plus 15 times a negative 1. This now is a negative 15, yes? So 8 minus 15 turns into a negative 7, and then plus 22i. Last two, hang in there. Now when we're asked to simplify this, when we have a plus and 2i on the bottom, what we have to do, and it's called a conjugate, we have to multiply the top and the bottom by the conjugate, and what we do is change the sign. So we are multiplying everything, top and bottom, by 3 minus 2i. And so when we do this, we multiply out the top, and that gives us here and there, it gives us a 15i minus 10i squared. Then on the bottom, we multiply everything out to get 9 minus 6i plus 6i minus 4i squared. Well, our I squareds turn into negative 1. Turn into negative 1. So now on top we have 15i plus 10. Do you agree? Because the negative makes that a positive. And then makes this a positive. So it's 9. These guys cancel out to get plus 4. We simplify to get 15i plus 10 over 13 for your final answer. Now a 16, again, we cannot have i's in the bottom of fraction, so we have to multiply that out of there. How do we do that? Well, I'm just going to multiply top and bottom by 2i and 2i. There is no plus or minus sign down there, so I don't have to change anything. So on top, I get 10i plus 2i squared all over 4i squared. What do your I squareds turn into? Your I squareds turn into negative 1 and negative 1. So now, on top, we have 10i minus 2 and a negative 4. Simplifying, we get, taking a 2 out here, we get a, actually I'm going to pull things apart. It's going to be a 10i over a negative 4 minus 2 over negative 4. Cleaning things up one more time, I can take a 2 out there to give me a negative 5i over 2, and then plus 1/2. And that does it for section 4.4, complex numbers. Sorry, I went really fast. Have a good day.